Hello children, welcome to aimsindia's online classes. In today's video, from mathematics subject, pair of linear equations in two variables. That topic we are going to discuss. So here children, so let's start with one example, one real life situation where we will come across this usage of pair of linear equations. So Akila went to a fair in her village. So she wanted to enjoy rides on the giant wheel and play hoopla. Hoopla is a game where you will give some money and you will buy some rings and some items will be kept on the table, or you will be given gun and some items will be kept on the surface, so that if you throw the ring on any item, that item will be yours. Or if you, with the gun, if you hit any of the item, that item will be yours. So that is hoopla game. So she want to enjoy ride on giant wheel, and she want to play the game of hoopla. So here, so the number of times she played hoopla is half the number of rides she had on the giant wheel. Suppose on the giant wheel, if she had X rides, if she has taken X rides on the giant wheel because it is unknown, then number of times she played hoopla game is half the number of rides on giant wheel. Means if the number of times played on hoopla is Y, which is equal to half of X. So Y equal to half of X. So this is the situation here. This is the first hint given. And one more thing, if each ride costs ₹3 and a game of hoopla costs ₹4, means for having one ride on giant wheel, she has to pay ₹3. For playing one time this hoopla game, she has to pay ₹4. So how would you find out the number of rides she had and how many times she played hoopla, provided she spent ₹20 altogether? So for each ride, ₹3, and for each game, ₹4. So overall, she has spent an amount of ₹20. So now we have to find, so how many number of rides can be possible, how many times of hoopla games can be possible with ₹20 and with satisfying these two conditions. So in this kind of situations, we will come across this linear equations concept, children. With the help of a pair of linear equations in two variables, we have to solve the question. One variable is X here, number of rides taken on giant wheel. Another variable is Y here, number of games played, number of hoopla games played. So we have two variables, and Y equal to X by 2. That is one situation, one equation, and each ride ₹3. Number of rides X. ₹3 into number of rides X. Each hoopla game ₹4 into number of games Y, which is equal to 20. So this is another equation. So we have two equations. So Y equal to X by 2 and 3X plus 4Y equal to 20. If we solve these two equations, we will get the values of X and Y. So Y equal to half X. So 3X plus 4Y equal to 20. If we solve these two, we will get the answer. Or 2 into Y. We can write the first equation as 2Y equal to X. Means in the place of X, we can substitute 2Y. So here 3. In the place of X, we can keep 2Y. plus 4y equal to 20. 3 into 2y, 6y plus 4y equal to 20. 6y plus 4y, 10y equal to 20. So y equal to 20 by 10, which is equal to 2. So if y equal to 2, then x equal to 2 into 2, that equals to 4. So x equal to 4, y equal to 2. So x means number of rides taken on giant wheel. She has taken 4 rides on giant wheel and she has played hoopla game 2 times. So that is the answer. Let's see another situation, children. So one day Siri went to a bookshop with her father and bought 3 notebooks and 2 pens. She has bought 3 notebooks and 2 pens. Her father paid 80 rupees for them. Altogether, her father paid 80 rupees to the shopkeeper. Her friend Lakshmi liked the notebooks and pens, so she bought 4 notebooks and 3 pens. 4 notebooks and 3 pens of the same kind, means of the same rate, and paid rupees 110 in total to the shopkeeper. And again her classmates Rubina liked the pens, Joseph liked the notebooks. They asked this Siri the cost of 1 pen and 1 notebook, but she didn't know because her father gave the money. She didn't know the cost of 1 notebook, 1 pen separately. So now the question is, how can they find the cost of 1 pen, 1 notebook, or cost of items? So here, cost of notebook, cost of pen are not known, unknown terms. These are unknown quantities. So in our real life, we will come across like these situations in our daily life. Now our main task is, if Siri has brought 3 notebooks and 2 pens for rupees 80 and Lakshmi has brought 4 notebooks and 3 pens for rupees 110, so what will be the cost of 1 notebook? What will be the cost of 1 pen, so that they can guide this Rubina and Joseph. Rubina and Joseph. Here cost of notebook is unknown, children. Cost of pen is unknown. These are unknown quantities. Now how do we find these unknown quantities? That is the main task. So Siri has brought 3 notebooks, 2 pens, rupees 80. So this Rubina and Joseph tried to guess. What is the cost of notebook and pen. Rubina said that price of notebook will be 25. So 3 notebooks she has brought. 3 into 25, 75. Then remaining 2 pens are remaining. Out of 80 rupees, 75 rupees already completed. So only 5 rupees. 2 pens will come in 5 rupees. So each pen will be 2.5 rupee. 2.5 rupee. Like that, she had a guess. So now Joseph, what he has felt, he felt 2 rupees 50 paise for 1 pen was too little. He told, you are guessing cost of notebook high and cost of pen you are guessing very low. It may not be true. It should be at least rupees 16. 16. Like that he told. So cost of a pen 16 told. 2 pens. 2 into 16, 32. Out of 80 rupees, if 32 rupees goes means, what is remaining? 48. In 48 rupees, 3 books. Means notebook also will be 16 rupees. Notebook cost also will be around 16 rupees. So like that, they are guessing. So we can see there may be as many possible guesses for notebook and pen, so that total cost will be 80. So like this, we can have so many values for notebooks, so many values for pen, such that if we add total, the amount will be rupees 80. Rupees 80. So means based on only this series condition, we cannot find the cost of one notebook, cost of one pen, definitely. So based on only series situation, we cannot find the cost. We have to include Lakshmi's situation also. So Lakshmi also brought same types of notebooks, same types of pens as Siri. So cost will be same. She paid rupees 110 for 4 notebooks and 3 pens. So if we combine two situations, if we observe two situations, 3 notebooks plus 2 pens, 80 rupees. 4 notebooks, 3 pens, 110 rupees. 110 rupees. So then, what will be the So according to Rubina's guess, what she has told, one notebook 25 showed, she has told. So based on series situation, she guessed one notebook cost will be 25, one pen cost will be 2 rupees 50 paise. Let's apply these two for Lakshmi. Lakshmi has bought 4 notebooks, 3 pens. So 4 into 25, 100. 3 into 250, 750, which is equal to 10750. But she paid rupees 110. So Rubina's guess was wrong. So what about Joseph guess? Notebook 16 rupees, pen 16 rupees. Let's apply to Lakshmi's situation. 4 notebooks, 4 into 16, 64. 3 pens, 3 into 16, 48. 64 plus 48, 112, which is more than she paid. So Joseph guess also wrong. So based on only one condition, we cannot guess the two values. So if we have only one equation but two unknowns, two variables, we can find many solutions. Like Joseph Rubina. When we have two variables, we need at least two independent equations to get unique solution. So for finding the exact solution, we need at least two independent equations. So one way to find the values of unknown quantities is by using the model method. Now we are making use of model method, and this method we will apply to series situation and Lakshmi's situation, and we will find the unique solution. In model method, rectangles are proportions of rectangles often used to represent the unknowns. So here, suppose the notebooks, let's represent notebooks by this red color lines, rectangle, and represent pens by this blue color rectangle. Now, Siri has brought 3 books, 2 pens, rupees 80. So 3 notebooks, 2 pens, 80 rupees. Lakshmi has brought 4 books, 3 pens, 110. 4 books, 3 pens, rupees 110. Now, in step 2, we have to increase or decrease the quantities in proportion to make one of the quantities equal in both situations. Means in both situations, at least one quantity to be equal. Like that, we have to increase or decrease the quantities in proportions. So what we are doing, 3 books. Previously we have 3 books, 2 pens. what we are doing, we are multiplying with 3. We are multiplying with 3. So 9 books, we are multiplying with 3. 6 pence. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 books. 1, 2, 3, 4, 5, 6. 6 pence. As we are multiplying with 3, we are multiplying books with 3. We are multiplying pens with 3. We should multiply amount also with 3. Then total amount will be 240. Second situation, we have 4 books and we have 3 pens. Now here we have 6 pence. If you want to make them equal, here also 6 pence. This 3 pence to be multiplied by 2. So first books also to be multiplied by 2. Amount also to be multiplied by 2. So 4 into 2, 8 books. 3 into 2, 6 pence. 110 into 2, 220 rupees. So by multiplying with the same number, we have made the number of pens equal in both cases. Number of pens equal in both cases. Both cases. So now if we compare this these two situations, this 1, 2, 3, 4, 5, 6, 6 pence, 6 pence cancel. Here 9 books are there, here 8 books are there. So we can cancel 8 books. 8 books, this 8 books cancel. So equal amounts gets cancelled. So what will remain? Only one extra book. If we remove these two, if we subtract, if we take the difference of these two proportions, we will be having only one extra book. We will be having only one extra book. And amount, out of 240, if we remove 220, the amount will be remaining 20 rupees. So one extra book costs rupees 20. We can come to that conclusion. So by this model method, after comparing 1 and 2, we can easily observe that one extra book costs 20 rupees. One extra book costs 20 rupees. So each book costs 20 rupees. So Siri has brought 3 books, 2 pence for 80 rupees. But each book 20 rupees. Then what about 3 books? 3 books cost 60 rupees. 3 into 20, 60 rupees. So cost of 2 pence will become, out of 80, 60 rupees for books. 20 rupees will be remaining. In that 20 rupees, she has bought 2 pence. So what about 1 pen? 20 divided by 2, which is equal to 10. Which is equal to 10. So now we got, by model method, we got notebook cost rupees 20 rupees and pen cost rupees 10. So let's apply this to Lakshmi's situation. She has bought 4 books. 4 into 20, 80 rupees. She bought 3 pens. 3 into 10, 30 rupees. So 80 plus 30, 110 rupees, which is true. Which is true. So we are getting exactly one solution. Cost of book is 20 rupees. Cost of pen is 10 rupees for one variable and for other variable. For 2 variables, we have got the unique solutions. Unique solutions. Why this happened means because of 2 independent linear inequations. As we have 2 independent situations which are having same two variables, same notebooks, same pens, same 2 variables. So that's why we are able to solve the 2 equations and we are able to get unique solution. So in general, an equation of the form ax square plus bx plus ax plus by plus c equal to 0, where a, b, c are real numbers, where at least one of a or b is not 0, is called a linear equation in 2 variables x and y. two variables x and y. Means which is in the form of ax plus by plus c equal to 0, and where a, b, c, r belongs to real numbers, and at least a is not equal to 0 or b is not equal to 0. At least any one of them should be not equal to 0, or this condition only can be represented as a square plus b square is not equal to 0, because if if both will become 0, this total sum will become 0. This will not equals to 0 when at least one of them is not equal to 0. So this condition can also be represented as a square plus b square is not equal to 0, which means at least one of them is not equal to 0. So actually in this form, if you have equation satisfying these conditions, this will be an equation of, this is considered as linear equation in two variables x and y. So ax plus by plus c equal to 0, where a comma b comma c belongs to R, where a square plus b square is not equal to 0, which means a is not equal to 0 or b is not equal to 0, which means at least any one of them not equal to 0, then this ax plus by plus c equal to 0 is considered as linear equation in two variables x and y. X and y. So if we have two equations, so a1x b2y b1y plus c1 equals to 0, and a2x plus b2y plus c2 equal to 0. So then if we have two independent equations in variables x and y, then we can solve the values of x and y. Let's try these questions, children. So mark the correct option in the following questions. So which of the following equations is not a linear equation? Linear equation means it should have highest power 1. So here no power is 0, variable power is 0, here 1, variable power is 1, here no variable power is 0, highest power is 1, two variables are there. It's a linear equation in two variables. This is also x plus 2y, linear equation in two variables. But here in C example, we have y square whose power is 2, which is not a linear equation. So option C is not a linear equation. Fourth one, power 1, linear equation. Next one. So which of the following is a linear equation in one variable? In A option we have two variables x and y. Wrong option. We have only one variable t here and the highest power is 1. So it's correct answer. We have power 2 x square. It's not a linear equation. We have power 2 x square. It's not a linear equation in linear equation. It's a quadratic equation because power is 2. So option B is correct. So which of the following numbers is the solution for the equation 2 into x plus 3 equal to 18? A option 5. 2 into 5 plus 3. 2 into 5 plus 3. 5 plus 3 is 8. 2 into 8. 16. Wrong option. If you keep 6, 2 into 6 plus 3. 2 into 9. 2 9 times 18. Correct option. Next, the value of x which satisfies the equation, this equation, is A option 4.5. 2 into 4.5, 9. Minus 4 minus 4.5, 0.5. 9 minus 0.5, 8.5. So 8.5 equals to 5 minus 4.5, which is equal to 0.5. Wrong. Next 3. 2 into 3. 2 into 3 minus 4 minus 3 equal to 5 minus 3. 2 into 3, 6. 4 minus 3 is 1. 5 minus 3 is 2. 6 minus 1 is 4. 4 equal to 2. Wrong. 3 is wrong option. Next 2.25. 2 into 2.25 minus 4 minus 2.25. So 2 into 2.25, 4.5. 4 minus 2.25, we will get to 1.75. 1.75. 4.5 minus 1.75 will be equal to 2.25. Sorry, 2.75. 2.75. This is LHS. RHS. 5 minus X. 5 minus 2.25 equal to 2.75. So this is true. So C option is true. The equation x minus 4y equal to y has, we have only one equation. So if x equal to, suppose if y equal to 1, we have x, we have 4y, we have x minus 4y, or this equation can be written as x equal to, 1 minute, they have given x minus 4y equal to 5, x equal to minus 4y will go that side, 5 plus 4y, like that we can write. We can take y value, we will get x value, means when y is 1, 4 into 1, 4 plus 5, 9, x value will be 9. When y is 2, 4 2 times 8 plus 5, 13. When y is 3, 4 3 times 12, 12 plus 5, 17. Like that, for different values of y, we can have different values of x. So we can have infinitely many solutions. When we have only one equation having two variables, we can have infinitely many solutions. Suppose when we have two equations in same variables, then we can have only unique solution. But if you have only one equation, we can have infinitely many solutions. Okay, children, let's discuss the remaining topics in our next video. So thank you for watching our video, children. So please subscribe our channel and press the bell icon for receiving latest updates. So you can also visit our website aimstoday.in for other information regarding online classes, quizzes, worksheets, activities, English classes and coding skills. Thank you, children. Have a good day.